Good morning, rock stars. Today we are going to first go over your two problems from yesterday's lesson where we were using Pythagorean theorem to discover the missing sides of the 45, 45, 90 and 30, 60, 90 triangle provided. And then you are going to see how these triangles help us form the coordinates or the ordered pairs of your unit circle. This unit circle is going to become your best friend, so get excited. I have it copied on my whiteboard over there, which does not look anywhere near as fabulous as this one does, but we will make do. So let's start with our do now. So we want to use Pythagorean theorem, which I know everyone in their head is already like a squared plus b squared equals c squared, to solve for the missing sides of this right triangle. So I have that on my whiteboard over here, and I want you guys to just notice here that one of my sides is already labeled with a length of 1. And that side, which a lot of you guys already discovered, was your hypotenuse. So my hypotenuse there has a length of 1. My hypotenuse is always my c value in my Pythagorean theorem, so I know that my whole equation is going to be equal to 1 squared. Now some of you guys got in the habit of writing a squared plus b squared equals c squared, and you just copy down a squared plus b squared. But even though we don't know what these values are, I still want to substitute them in for a and b. So I'm going to write a just as x squared. I'm going to assign, let's just say, this to be a, and then this side to be b. So I'm going to plug x in for b as well. So I have x squared plus x squared equals 1 squared. Yes, Lyra, we already know that 1 squared we can go ahead and write as 1. And we can look at this x squared and this x squared here, and you should be thinking that, oh, these are like terms. So Danny, when I combine those two together, you are absolutely going to get 2x squared. Your power does not change there. It should just be staying as 2x squared. Now you just want to solve for x. So we're going to go ahead and divide by 2. And I have x squared equals 1/2, and you are going to take the square root of both sides. So I'm going to have x equals, and a lot of you guys wrote your answer like this, but for this scenario here, I actually want to express it in simplest rational form. So I'm going to go ahead and look at these both separately. Square root of 1 divided by the square root of 2. Well, we know that the square root of 1 is just going to give me 1. And the square root of 2, that's not a perfect square, so I'm going to keep that there. However, math jail has this thing against having the square root in your denominator. It's kind of like having 0 in your fraction. We just don't like to see that. So I'm going to go ahead and get rid of this. I'm going to rationalize my denominator by multiplying your numerator and denominator by whatever is in there. So in this case, it's going to be the square root of 2. And when you do that, I'm going to have the square root of 2, because 1 times the square root of 2 is just going to give me that. And here my square roots are going to cancel out, and I'm just going to be left with the with 2 in your denominator. So over here, I have my final answer as x equals square root of 2 divided by 2. And that's what both of your x values here are equal to. So that's how you go ahead about rationalizing your denominator. You multiply it by whatever is underneath your square root. That's how you rationalize it. And what you do to your denominator, you must do to your numerator. All right, that's your first example. Your second example here with my 30, 60, 90 right triangle. I gave you guys a huge hint yesterday, and I said, why don't we expand out and form an equilateral triangle here? If I do this, then I know that this side is going to be 30 as well. And this is going to be 60. Well, if this side has an angle of 60, this whole angle here is actually going to be 60 degrees, which gives you all of your sides here a measure of 1. Because it's an equilateral triangle. But now if I only want half of that base here, then I know that this simply right there has to be 1/2. because you have half of your base. That's what's happening there. And now you can go ahead and use Pythagorean theorem to solve for what this side is going to be, that x. So I'm going to have 1/2 squared plus, let's just say b squared or x squared, whatever you want, equals to 1 squared, sorry. And now you're just going to go ahead and solve. I know that 1/2 squared is going to leave me with 1/4 plus b squared equals 1. Max, you do subtract 1/4 from both sides. You're going to have b squared equals 3/4. Yes, we do take the square root of both sides here. So I can rewrite this as b is equal to square root of 3 over square root of 4. Or if I really want to express this in simplest form here, I can go ahead and write that as b equals square root of 3 over 2. And that's the measure of this side here. So I have the square root of 3 over 2. I know you can't really read that, and I apologize. This marker is like very square root of 3 divided by 2. There we go. Alright, so this was yesterday's example. Some of you guys did an amazing, everyone did really good with your first example. This exploratory problem was for sure a challenge, and I'm really proud of the hard work that you guys did. But that is what you can use to check yourself. Alright. These two triangles are going to play such a key role in your unit circle. So we're going to come up with all of the ordered pairs on this diagram. So I want to know basically, like, at 30 degrees, what is that actually as a coordinate? At 45 degrees, what is that going to be as a coordinate? That's what we're filling out here. So we're going to learn, like, what is my x value and what is my y value at 45 degrees? What is my x value? What is my y value at 30 degrees? So in order to do that, we must first recall that the unit circle has a radius of 1. How do I know the unit circle has a radius of 1? Well, you guys just proved it all up here. Notice your hypotenuse, your longest side there, was always equal to 1. So remember, like here, my radius from your center of your circle, that means that this has a length of 1. This line has a length of 1. This line has a length of 1. This line has a length of 1. Notice the angles too. Those are all coming from the triangles that you just formed here. Alright, so let's do some exploring. First off, at 0 degrees here, if I wanted to write this as an ordered pair, my x value comma my y value. Well, since my radius here has a length of 1, I know that my x value here has to be 1. And I didn't move up and I didn't move down at all, so that means that my y value is 0. So we can go ahead and write this ordered pair here as 1, 0. That's what that is right there. If I wanted to do the same thing for 90 degrees here, I can label this 90. Okay, well now I want my radius, I went up 1, but I didn't move to the right and I didn't move to the left. So that means that my x value here is 0 and my y value is 1. Over here, okay, my radius, again, we know that that's equal to, this is 180 degrees. We know that that's equal to -1 because now I'm on the negative side of my graph. But again, I didn't move up or down at all, so that means my y value has to be 0. You guys can go ahead and do this one and check yourself. For 270 degrees, I'm going to write it down here. 270 degrees, we should have -1, 0. Alright, so you guys just discovered the basic ones of your unit circle. So your 0 degrees, 90 degrees, 180, and 270. Now we're going to go ahead and discover all of those values in between. So let's start with 30 degrees. I know that if I'm looking at my 30 degrees here, I should be looking at my 30, 60, 90 triangle. And since that is the case, my 30, 60, 90 triangle, I already know that the length of this side here is 1 because that's coming from the center. That's my radius. Well, now, what is my y value at this point, and what is my x value? You might do some noticing, which is the best way to go about it. This line is certainly longer than that line there. So since that's the case, my x value here has to be the square root of 3 over 2. And then that leaves with my y value of 1/2. Because that's the measurements of your 30, 60, 90 triangle. 45 degrees, you guys are lucky because the only possible directions of your 45 degrees, Sam just pointed out, is going to be square root of 2 divided by 2, comma, square root of 2 divided by 2, because these values are the exact same. So that's always a safe one. Now 60 degrees, okay? Again, drawing my line. So I want to know what is my x value and what's my y value. Well, now notice my y value here is the longer one, and my x value is the shorter side. So that means my x value here is actually going to be 1/2, and then my y value is going to be the square root of 3 divided by 2. Alright, so now you guys just did all of your key features for quadrant 1. The good news is those are the values that they will ask you about only. Now, I want you to notice we're going to focus in on quadrant 2. Something very specific happened in quadrant 2, your x value and your y value. So my y value from quadrant 1 and my y value in quadrant 2, it stayed the same. But my x value in quadrant 1 to my x value in quadrant 2, it actually flipped, it negated itself. So that's the pattern that's going to happen here because I know all of these x values here are negative. So at 120 degrees, if I had a perfect circle, which I unfortunately don't, but like lucky for you, on your paper you do, I know that if I drew a line there, that they are symmetric. So that means that at 120 degrees, this measure of x and y value is going to be negative 1/2, comma, square root of 3 over 2. And that's the measure of that side there. At 135 degrees, well, the same pattern is going to happen. Okay, it's symmetric. So I know that I'm going to have negative square root of 2 over 2, comma, square root of 2 over 2. So my y values are staying the same, and my x values are flipping. This pattern is going to continue. Now when you get to the third quadrant, you're going to do 150 on your own. When you get to your third quadrant here, start comparing this. Like what is going to happen at 150 and 210? Your x values should be negative. Oh, and my y values now have to be negative because I know that's what happens in my third quadrant. All right, so you're going to go ahead and get all the labeling for your unit circle, and then you're going to practice on what are some of your ordered pairs at specific angles. Good luck. We will have a Google Hangout on Wednesday to review this. Have fun.